Hey everyone, it's Norm from Tested here.
And Sean.
And we have the Frontier ship that we built for Bethesda for their game Starfield. An incredible project. We had so much fun working on this. And Sean?
Well, we got permission to release the files as requested. Now, we will say that they're not the 3-foot long files.
That's right. That's right.
Because most people won't be able to handle that. So we've done something a little more obtainable for most people that you should be able to do on most resin printers that you would have at home.
Yeah. So if you just want to get the files, there's going to be links in the description for where you can download those. But in this video, we'll be walking through the assembly process of how to turn those 3D printed files into a model, a 12-inch long model of the Frontier ship, as well as diving a little bit deeper into, Sean, your process.
Yeah, we had a lot of questions.
Yes, of turning a video game model into a 3D printable object.
Yeah, so hopefully there'll be some helpful tips.
Yeah, so let's start with that, because that was part of the journey that I think we talked a little bit about in the series, but most of our build videos were about the physical assembly, when so much of it was done beforehand.
Yeah, it's a lot. It's not an easy process, and a lot of times people get very intimidated by that, especially if they don't have a lot of 3D modeling skills or experience or anything like that. So I'll kind of walk through some of the things that I do, and hopefully for those who even do this already, maybe it'll be helpful.
Totally.
So typically you start with the asset, because a lot of times we're either working with like a film or TV production or games. And
that's what you have lit up here. Your program of choice is Cinema 4D.
Yep. Very much like Maya or Blender. It's just what I've been using since grad school, and I kind of stuck with it.
Mm-hmm.
Yeah. So this is exactly how we got it from Bethesda. It obviously has a lot of extra stuff like the thrusters, and there's all kinds of little markers for who knows what. And there's also all geometry for decals and stuff like that we weren't obviously going to print on the model, but we're there to put artwork on or textures on. Mm-hmm. So the first thing I had to do, and this is true for any model, is you have to strip out all the stuff you don't need. So that basically ended up being all of this stuff, which we showed before. So all of this stuff is just extraneous for 3D printing purposes, and it all had to be stripped out. Now, when I do that, I don't delete it. I put it in an unused folder, because you never know when you're gonna need to go back to it. So for example, we went back to this to get the decals that we made for the loading ramps and the masks for the cockpit windows.
Right, right.
So keep it, just hide it, and don't have it shown. So then we end up with all of the parts that we want. And then the other things to do is you want to zero that out. So you want to make sure that it's as close to the origin in the 3D space as possible. At the very least, you want it, like if you're looking down the length of the ship, you want it zeroed this way. And that's going to help us with symmetry stuff down the road. Yeah. Up and down is not as important, but you might as well do that.
And we discovered left and right symmetry actually was really important.
Super helpful for
duplicating parts, mirroring parts, even the exact same part, just flipped 180 degrees, used on the other side.
So I will zero it out. I will then scale it. So in Cinema, you can actually scale it to actual inches and millimeters or whatever. You may not have that. You may have units in yours, so you have to decide what your units are going to stand for and stuff like that. And when you do that, this is like the number one thing I always have to ask people when I get something that they want me to 3D print is a reference cube. So a 10 millimeter is a good cube. So just make a 10 millimeter cube that lives with the project. It gets output either with the model or in the same folder as the stuff, so that when you bring it in to 3D print, you can verify that that is 10 millimeters, and then you know all the rest of the parts are the right size. Because that is a danger of printing things at the wrong size. So then we're going to separate out all the parts. So we've separated it out to like the cockpit, the thrusters, all this stuff, and color code it. Color coding it will make it way easier for you to pick the pieces out.
I got a question for you. Yeah. So because the file was like one OBJ, the parts were not seamed necessarily, right? Or were they already?
It can vary. So sometimes you get a file and everything is just Starship and it's one model, and all the different pieces are combined in the one model.
Contiguous mesh.
So you can go through that and say split into polygon groups, and it will go through and find all the things that aren't connected and separate them out. In this case, Bethesda already had everything separated out into groups, which made things a lot easier, other than having to clean out all the extra stuff. The problem is a lot of times I just like name somewhat generic, or some things might just be called cube. The big stuff they had named, but not all of it. So the other thing is you want to separate it out, color code it, and name it. You need to name it so you know what the heck all of that stuff is. You don't have to do every single part, but make everything grouped together and call it cockpit or whatever.
And you're basically, in that first pass, you're hiding things and revealing things, grouping your things, and doing a visual pass on it for what you want to keep.
And it kind of helps you wrap your head around and be like, okay, this is what I'm dealing with. Because like I was really intimidated with this at first. It's like there's a lot of stuff.
Yeah.
But because they're modular in game, as I started to figure that out and see how it all worked, I was like, oh, this is making sense now. And then the other thing that I will do is go through and pick out symmetrical things. So for example, our engines are symmetrical, some of the landing gear and the thrusters are, the lasers and stuff like that. So what you end up is picking out, here I'll turn on and off the stuff. You end up picking out stuff like this. So basically, I got rid of the whole right side of the ship and only kept the left side, because you don't want to have to repeat work on fixing this landing gear and then fixing this landing gear, which is a mirror. So you can get rid of symmetrical things, just work on one and then use it. And actually, you don't even need to mirror it actually in the program, because it's going to be a 3D print. You just need one good one and it mirrored for output.
In your slicer, or however you print it.
So like all of these parts basically were parts I didn't have to work on twice. Yeah. So then the other thing that you would want to do, that I typically do after all of this, is I will, if you can in your program, I do what's called freeze transformations. And what that means is it just locks everything at the scale, the rotation, the position that it currently is in. So what that means is I could grab like the cockpit and I need to do something and I drag it away from the model and I'm doing whatever. I rotate it, I do whatever, and then I can hit the reset button and it goes right back to its home base.
But it inherits any of the changes you might have made just to that object.
Exactly. So it'll keep changes that I made to it, but it won't change the position or anything like that.
Rotation.
So
got it.
that way you can move things out of the way or move things around to like check things and then hit that reset button and it goes right back. On mine, it's called freeze transformations, and there's a PSR button which makes it go back to 0. It's 0. You're basically creating its own origin point. And you can do that in Blender and other programs. I just don't know the particulars for that. But that is super, super helpful. I've also gotten in these projects where I accidentally nudged something, and I didn't realize it till way far, and I'm like, oh crap, everything I just did is totally off now because that part got nudged.
Yeah.
So it helps with part nudges as well. Now we're moving into fixing parts, right? So we talked about doing the symmetry for big parts, but the other thing you want to do is do symmetry for actual individual parts. So like we have the reactor here, right? So there's, once again, so much stuff on it, so many tubes, so much stuff. And I don't want to have to fix both sides of this, so I basically cut this down the middle. Sometimes you'll have to put an edge line like right on the 0 mark, and literally I select all of those polygons and just delete half of it. And then we drop that underneath its own symmetry so that we only work on this side and there's only polygons existing on this side, and then we have the computer mirror it for us. So that saves you a ton of work instead of having to jump back and do things twice. Cut it in half if you can, do it on one side, and then have the computer mirror it for you. And then you can export this under the symmetry and it will be all set to go.
Symmetry is one of those things that you're kind of almost reverse engineering how the original artists may have created it, because sculptors, hard edge modelers use symmetry as a way to build up their models quickly as well, and you're taking advantage of that.
I use it all the time.
Yeah.
And this is why it's important to zero it, because then when you cut that, it's down the 0 mark and everything will be mirrored perfectly. So symmetry on individual items as well as pieces like landing gears.
Color coding those as well.
Yep, color coding everything. And then the other thing, then we have to start looking for problem parts. I think the #1 problem part that I have when doing production models is floaters. And floaters are basically when you have some kind of surface detail like a grill or a vent or something like that, and it's on the surface of the model, and you zoom in and zoom in and zoom in. If you zoom in enough, you find that it's floating like fractions of a millimeter above the surface. It's not actually embedded in the surface.
Grafted on.
Yeah. So when you throw that in a 3D printing program, it's like, and it'll try to print this thing floating in space, and then you'll get these little things floating in your tank of resin. So, or if it's an FDM, like printing in midair or something like that. So floaters are a huge problem. And when I go into the repair program, what you want is one shell. So ideally you want this piece to be one continual shell or one piece. And if you have like multiple shells, then that's a warning sign saying something's not right. So in this case, I had a terrible time with the top cow getting it to pass mesh repair for printing.
That's this
I
piece right
could
here.
not figure out what the heck was going on. So like it took me hours of fiddling around, and I finally figured out that these four little red fins,
Oh my gosh.
these four little tiny red fins, which are like barely there,
Yep.
they're floaters. So if we go inside the model, so we see these red ones here, right? We're going inside, and we look above. They're not there.
They're not
They're not
there.
sticking through.
Wow, it's the digital equivalent of a greebly
Yeah,
that was
like-
just set in place but not super
Yeah,
glued
so
on.
you can see a little bit of them sticking through, but they're not sticking through the whole way. The other problem is they're not watertight. So they're an open mesh, which is fine. You do that all the time to save on processing, but they don't have an actual back or ends to them. So all of those things, them being floaters and floating above the surface, and them not being watertight, kept throwing errors like crazy. And these are so tiny. It took me forever to find that. And sometimes the programs can point out problem spots, but it doesn't always catch everything. And that's just one that I didn't catch in the mesh repair. So that basically what I had to do is just I had to make these watertights to put it back on them and then push them down into the surface of the model so that they are part of the main piece now.
And then do you merge them in some way?
Yeah, at this point, I don't do that. I do that in the mesh repair software. But yeah, I do end up merging them. And once again, we've done the symmetry where we just worked on one half of this.
Awesome.
The other problem you run into are unconnected panels. So we showed this briefly in on the engines when we did the original videos, but this is our original engine, and it's color-coded into what pieces are making it up right now. So the engine is a whole bunch of panels that have no dimension to them that are all just kind of stacked next to each other. And if you zoom in, zoom in, zoom in, you'll find out that the little vertices and stuff like that are not actually touching in a lot of places. So these panels are not actually connected. They're really close to each other, but they're not truly touching, and the vertices are not actually there.
Yeah.
So there's a few things you can do with that. Sometimes you have an optimize option where you can say, if these 2 points are this close together, merge them. So this took a lot of fiddling around and figuring out where the openings were and where the problems were. And these yellow fins were floaters, and I had to make sure that they're all sunk into the surface and all that kind of stuff. So looking for panels and making sure that they're connected is a big thing. Sometimes what I'll do is use fillers, and that's just like generic shapes that I'll put behind things to just close a gap. So like we had all these little greeblies, like the hoses and stuff, and then there's a big hole back there. So this blue that you can see in there is a filler that is just brought up behind them to still have the relief of those, but like fill that hole.
There was a shape. You could be just a flat edge shape. As long as it intersects with every point here, when you repair it, it will merge it all.
So I use fillers all over the place. The engine also demonstrates the faceting problem that you get on some of the models. So like it's real chunky up here. And on our big guy, that totally would have shown up. So the other thing you got to do is go through and do smoothing. So I have smoothing algorithms applied to these to make them look a little nicer. Sometimes this is as good as I could get. Sometimes you need to rebuild the part.
And it's one of those things that we made the decision as we were working through these models and deciding how much at the scale we wanted to keep. You know, we actually decided the faceting would catch light in an interesting way.
Yeah,
you know, we made some aesthetic
and it
decisions.
kind of worked with those engines. And sometimes you just leave that till last and you get all the important stuff, like, oh, it goes together.
Yeah, right.
Then if you have time, we revisit that, and those are bonus, you know, because a little sanding can often help get rid of those. Sorry, Kate. So now the one problem we ran into is you'll notice that these yellow panels got a little funky. So we go from like the panel lines looking not too bad to like really getting weird and mushy.
When you use the smoothing tool.
Yeah, so sometimes you can't smooth without doing a lot more work. So this is an area that I had to leave alone, and I smoothed the areas that I could, and we did a little sanding elsewhere. The other thing that you need to ask yourself is, should I separate these parts out? So sometimes things might be part of a big unit. So like we got like the Docker up here, and like how many of these parts do we want to print as the main unit? How many things do we want to separate out for ease of printing?
And also you're making choices about hardware, physical hardware that you might want to use.
So that's another thing to ask. And then, so after you do all of this, we've done all of our repairs and we've done all of our stuff, I would recommend then doing a refreeze your transformations again so everything's locked where you have it. And then you're ready to go into the mechanics and assembly. So that's where, when we are showing all this stuff, where we did keys. So we did keys on a lot of parts. So just using square keys in a socket to like lock them together. You want to put a tolerance around those mechanical parts that fit together. And usually I start with, my starting place is usually 0.008 to 0.01 inches as a tolerance. So if that socket is 0.008 bigger than the key. And that varies, that can vary depending on material and the build and everything like that. So sometimes I tweak it, but it's usually in that ballpark is a good starting place. With FDM prints, you got to go a little bit more typically because of the lines or
have dimensionality. I mean, this is like the 3D equivalent of the kerf line, right? In laser cut. Yeah, you're compensating for the quirks of physical manufacturing.
That's part of what takes so long on this stuff is you have to make sure everything's going to fit together. So you have to figure out, how does this fit together? What things I'm going to use to make it fit together? What gets screwed together? What gets glued together? And because we knew we had to work on this a lot, everything was like screwed together, which then throws a whole other thing in there. And we talked about it before, but if you need to use hardware, make sure you're basing it on readily available real hardware. So like the rods that we used in all these places, I figured out what was the closest to what was in the game model and used that as a cutout.
Well, you can also download repositories of hardware.
Yes. So our favorite McMaster car, they have it built into Fusion 360 where you can just say, download this model from McMaster car. But you can go on McMaster car, look up a certain screw, and download the CAD model, drop it into your program. And that's what I did for all of this stuff.
That's how you would potentially build recesses, like countersink holes, all that stuff for your actual hardware.
Yeah, it's a lot.
That's a lot of work.
And dude, and order of operations is really tough sometimes because you're like, oh crap, I should have cut this out before I did this or whatever, and then you got to go back and do the whole thing again. So it took me a long time to figure out my do this, then do this, then do this. And once you get into that rhythm, it gets easier. Yeah. So after you do this, you're going to do one final mesh repair just because when you cut things or combine things, it can get a little weird. And then name it, name it well. So name it clearly. So, cargo bay version 1. If it needs to be printed twice, put a ×2, which we did in our files. If it needs to be mirrored, it's like ×2 and mirrored. So just make a description. And I always put a version on it because it never fails that I think I have it all done. And then I'm like, oh, nope, I've messed that up. That doesn't fit together. So I end up doing a revision. So then I know when I'm looking at that folder of stuff, if it has the old version or the new version, whatever. So all of these are numbered. You'll notice some of them are number 4. That's because I did it 4 times. So yeah, or if we ever have to do updates for the files, I'll be like, make sure you print version 2. So stuff like that. So always do a version, make sure you name them properly, and then you're going to export them for printing. Yeah. So like that's the thing. That's what I do.
Well, and the version of the files that we're offering that people can download that Bethesda's releasing, it's not exactly this model, and it wasn't as simple as you taking all the parts and say scale down this percentage and scale down. Right. Because even as you were taking that game model and creating that reference cube and us deciding in the conversations we had about the size of this ship, we made a decision based on the 3D printers that we knew that we were printing on. The largest part would fit in the volume of the Form 3L that we were using.
Yeah.
And for the model that's being released, you sized the largest parts
yeah.
for common resin printers.
Yeah,
that people
so
may
what
have
I
home.
did is I went and looked at all of the common, like Anycubic, Elegoo, all that stuff, and I found the smallest print bed on the most common ones, and I made sure that the parts would fit on that. So this should print, I think, okay on anybody's resin printer. And like you said, it wasn't as simple as just going zoop and shrinking it down, because we run into a few issues there. One, all the walls will get too thin.
Yeah.
Because if we went as small as we want, they'd be below 1 millimeter, and then we couldn't print it like that. The ribs would all be too skinny. Some of the details would be too small. All of the tolerances on our keys and stuff would be totally off. And then the other thing is, a lot of things like our little railings or our struts or anything would all of a sudden be too tiny to print. So yeah, so we scaled it, and then I basically had to recreate everything again. So I took all the parts that I'd combined and repaired, and I re-hollowed them. I made new ribs. Some things we printed solid this time because they were so tiny it didn't make sense to cut or hollow out. And then some things, like particularly the fuel tanks, these little railings were so tiny, I had to go in and like beef all of them up, like basically replace all of them.
And beefing means you're modeling new versions of them.
Yeah.
They're larger diameter. So at that scale, they will still print.
And our favorite part that Adam was cursing me for, the docker, this just would be impossible.
Right.
So what I did is I removed a lot of the lower ones that you don't really see, and then I made it in such a way that the detail's there, but it's faking it. It's like how they'd mold a plastic toy, like an engine or something that just has a surface detail, but it's actually backed. It has some meat to it. So we had to do a lot of stuff like that and basically redo the entire model. So all the parts that are on this are present here. It actually is in pretty much the same separate parts as the big guy. And we've even included the retracted landing gear. We did not include the loading ramp. It is closed because that was too much to handle in the time frame that we had.
It was even something we had to scratch build on the big ship.
Yeah, because it was going to be difficult to do, and even at this scale. There are a few places also where we're going to use some real metal parts if you want. It's optional. And I have some tips, some suggestions for like the railings and stuff if you want to be brave and tackle putting those on like we did. And I realize not everybody, like I said, this is optimized for resin printing. At the size we were working at and everything, these are resin prints. But I will include solid parts. So if you want to try it on an FDM printer, good luck. But it might actually let you also scale things up. So if you wanted to try tackling this size, you're gonna have to follow our tips on hollowing and cutting, but good luck. But they'll be there for those who want to mess with them. So,
and we did send the parts through, the Form 3. Printed a couple plates of parts out. They're actually curing right now. So let's reset out, get those parts out.
Yeah,
and let's do an assembly.
Show the thing. All right.
Sean, here are all the pieces.
Yeah, a little over 40.
Wow, and basically the same number we had on the big ship.
Almost. There's a few things that we combine, like we combine these into one piece versus separate, but it's almost exactly the same as what we did on the big guy.
So putting it together, shall we assemble it basically like we assembled it on the big ship?
Yep, and we're gonna glue things together. You just use super glue, will work fine. The only other thing that I would say is one option you may want to do is when you print this, is you could opt to print the cockpit in clear. Because I'm going to include the vector files for the cockpit glass mask. So if you wanted to print in clear, use the masks. You need a vinyl cutter. Well, I guess if you're really ambitious, you could print them out on paper and then transfer them to tape. But yeah, I'll include the mastic and mask out the window and paint it, and then have a clear window. Thing.
Yep,
yeah.
yep.
Yeah. But yeah, so it's pretty straightforward. You may need to do some minor sanding on the keys. So like where we have the keys that go into any of the sockets, you may need to do a little minor sanding on those depending on your materials and printer.
Yeah. And we printed this on a Formlabs Form 3 Plus using the Tough 2000 resin.
Yes.
Same resin that this is printed on, just for rigidity and low shrinkage. The tolerances are going to be tight.
Yes. All right, so let's do it.
All right, so should we start with the main body? And this is where you had your plate, right?
Yeah, this is the aluminum block. And I know people are a little upset when we did the original videos that we weren't calling things the right things. and in our defense, we got all this before any of the promotional stuff was out, so we didn't have any reference. But that is the HAB.
The HAB.
That a HAB.
Yes. All right. Yeah. With the HAB, we can go with the top or the bottom.
Yeah. So this will be in the print guide, so make sure you read the print guide. This is the back, so this little round cutout is the back, and this is the top. The one that has no cutout is the front cockpit area, and that, because this will determine how the landing gear sits, so make sure this is in the back and at the top.
All right.
Yeah. So the easiest thing I think to do is let's glue on the cargo bay and the cargo holds, so we can glue these together. So this is the hold, this is the bay, and we're just going to glue them together like so. Yeah. And then I did a little something different. I tried out some round keys, which actually worked really well because since we could do two of them, it will keep it from twisting, but it also keys it okay, and it doesn't need as tight of tolerances as the square keys do, so that was nice.
Still plenty of surface area for the glue.
Why don't you spray a little kicker on the pegs, and then we'll put it together. Excellent. I should have pointed this out before we glue this together, but I left holes in a lot of places, including the top of the cargo bay, so that you can try to put in lights if you want. I mean, little tiny LEDs would work really well in here. And I also included a file for the windows if you want to do clear windows.
Yeah, or we can just cut out some vellum and back it, sure.
Yeah, all right. So why don't you grab the back landing gear since it's near you, and I'll grab the front, and we'll put these together. And I should point out that, okay, the landing gear itself is symmetrical up front, but it's identical from diagonally. But this landing gear and the one back here are identical.
Yep.
So in the
but
files,
they are mirrored.
It's labeled
Got it.
left front, rear right times
the same
2.
thing. Yes.
Right. So and then the thrusters are the same way, but these are really hard to tell apart from left to right. So the left ones have a little square right on the back, and the right ones have a little circle. So that's how you can tell them apart. So right down there at the base, okay? And then the nozzles also have the same, except I maybe made these a little too small, but they are there, I swear. It's near the key. Near the keys, there's a little circle and a little square. You can't see them, but it's near the key here, so you can tell those apart as well. All right. And you can tell the landing gears, or the landing gear mounts apart, because front to back, the hole in the front is angled so, in the back, and you'll know immediately when you put the landing gear on because it'll be going the wrong way. Also, I don't know if you'll be able to get away with it on your printers, but on the Formlabs, I was able to print the landing gear just flat on the print bed with minimal support, and they turned out pretty good. You'll need to trim off a little bit of elephant foot that you'll get from there, but it's minor and easily done. We're going to glue in the nozzles, and if you look down in there, it's really not that big of a deal, and if you don't get it on it, it's not going to be the end of the world, but I put a little key in there so that the thrusters are aligned properly. And we're going to get that. This is a little tricky. You got to kind of jiggle it around and make sure it's on there. And you want to look down here that make sure that the fins are making contact with the bottom of the surface of the landing gear to make sure that it is on there properly. But it should look something like that. And that's it. That's your landing gear. So I call these landing clamps or docking clamps. And we had a lot of problem with these arms and these little guys breaking off on the big guy. So these were actual hole replacements that we had to do. So I made sure I made these really beefy and they're connected with the struts, so they should be okay. But these landing clamps have a little key on the bottom, and I would recommend gluing these on very, very last, like after everything is done. And then you go in and put a little dab of glue on there and glue in your landing clamps or docking clamps or whatever they are. And there are left and rights, so make sure you get the right ones going. Now I'd say let's glue on our landing gear. So why don't you, we will have to glue these on, so give those, each of those ports a little squirt of kicker, and then we'll go for it. All right, shall we do the top cowl?
Yeah.
And that's the docking section as well. So we need our cannons, our missiles, the lasers are for the cockpit. This is the shield generator and our fuel tanks. The engines just have keys. You can easily tell them left to right. They go into the reactor. And then once again, you have the separate nozzles. You could try putting lights in there if you want, and they just simply glue in place right there in the back. That's it. Okay, we're gonna glue the reactor onto the back. So I glue the engines onto the reactor and then glue the reactor onto the rest of it. So it just is a key once again, got some glue on there. Now, because the reactor and the engines are kind of heavy, I would recommend using a good amount of glue on this and making sure you hold it in place until it's dry so that they end up straight. Grav drive. So this is one of the places where we did leave some room to do some real stuff. There's little brass rods in here that you can add as a optional thing. It's not needed structurally, but these are 1/32 inch brass rods. You can easily get from like a hobby shop or Amazon or whatever. And they simply, what I would do is feed it in. And it just feeds the whole way through. You might have to finesse it a little bit or use some pliers to get it the whole way through. It'll poke through the other end. Put a little dab of glue on there. Pull it back like that, and then just snip it off flush. Wow. So that's a nice little upgrade, I think.
That's great.
Yeah. Okay, that's your back piece there, Norm. And I will put the lasers on. Are not symmetrical lasers. That is how it is in the game. I'll go ahead and put the cockpit on while you're doing that last bit of gluing. So again, the cockpit has a key. Ka-chunk. And these pretty much are the exact same keys we use for the big guy. I just changed the tolerances for it being small. And that was about it. All right.
Just about ready for that top piece.
Yeah, why don't you put some glue on that? I'll hit this with kicker. So we just had a little divots again like we used on the bottom. Yes. Cool. I think this is just a really nice size for being like, it's 12 inches long. It just is a really nice size for on your shelf. I'm really excited to see some people doing flying versions.
Oh my gosh.
With the retracted landing gear.
I mean, the thing that's impressed me most is also what amount of detail you're able to retain. Just the panel lines.
Yep.
Those just little bit of relief that you have there. That all reads. If you do a dry brush on that, that's totally going to read.
It does show up pretty well.
Yeah, and one of my favorite parts was when you guys were painting just all the silvering, all that like multiple chrome on all the metal struts here.
Yep.
That's going to read really well.
And part of the reason we did it as so many parts was it will make for better prints, and it will make it easier to paint. So you could paint it in sections like we did and then assemble it. and like I said, we'll have the paint list in there so you can go for it. So I'm looking forward to what everybody does with this. I hope you guys are happy now. We heard you and we made magic happen.
Oh my God, Sean, you're a magician. You're a wizard, Sean. Thank you so much for doing all the hard work on making this model printable. Not only the small one, the big one, of course.
It was a ton of fun.
Yeah, and thank you all out there for enjoying and watching the series. We'd love to see your models. Please share them with us, tag us on social media.
Yeah.
And all the details on where you can find these files that Bethesda's hosting is in the description below. Till then, have fun model making.